All right, hello everybody. My name is Sean. I'm a master's student, as Kiki mentioned, in Hydrology and Water Resources. And my project is titled Isotopes, Geochemistry, Citizen Science, and Local Partnerships as Tools to Build upon a Fractured Understanding of the Hydrology of the Patagonia Mountains. So I recognize that's a long title, and there's a lot going on in that. So I'm going to kind of anchor around that title and then describe the different components of this project as we go. So to begin, the Patagonia Mountains, they're not the Patagonia Mountains of South America. That would be great, but they're equally beautiful, maybe. So we're currently in Tucson, and if you look south, you'd see Mount Wrightson. And if you go over Mount Wrightson into the next valley, you would arrive in Patagonia, the town of Patagonia. And then the adjacent mountain range are the Patagonia Mountains. And the Patagonia Mountains actually extend south into northern Mexico. So important to this project is the Sonoita Creek runs through the town of Patagonia. And the Sonoita Creek is one of the few perennial creeks still in southern Arizona. And Harshaw Creek drains much of the northern Patagonia Mountains. So just a brief history to set the stage. The Patagonia Mountains have likely been inhabited for over 10,000 years. So similar to the Tucson Basin, they have seen and supported life for thousands of years. The Hohokam thrived there for approximately 400 years. And of course, it was part of Mexico until the middle of the 19th century. Patagonia was connected to many other southwest cities for about 100 years, and then the railroad stopped. And really important to this project was that it was mined for almost 300 years, and that mining has recently ended, but then the return of industrial mining to the mountains has recently commenced. So also very important to this project are the Sonoita Creek, which is integral to the work of over 30 stakeholder groups in the area, and those stakeholder groups are invested in the health of the creek. And Harshaw Creek, which drains much of the northern Patagonia Mountains and is the municipal water source for the town of Patagonia. And then the town of Patagonia, which is about 1,000 people, historic mining town. However, since the closure of those historic mines, it has developed a new economy based on art, tourism, outdoor recreation. All right. Okay, so now we've kind of set the stage of place, and we're going to talk about the hydrology. So the town and other people living in the area, there's a high level of concern about future flow conditions. So those future flow conditions being the Sonoita Creek, Harshaw Creek, and also groundwater availability. And though that concern stems from one, drought conditions. We're in the middle of an extended drought that's projected to continue into the future, and also increased mining activity in the Patagonia Mountains. And these are a few articles from the Patagonia Regional Times, which just address that level of concern. So getting a little bit more into the hydrology, Sonoita Creek, where does the water come from? So there's this perennial creek that runs through the town of Patagonia, and it sustains base flow throughout the year. Even if it doesn't rain for many months, it still has flow in it. Where's that water coming from? So recent research indicates that about 15 to 25% of that base flow in Sonoita Creek comes from the Patagonia Mountains. So what that says is impact or changing conditions in the mountains may impact the flow in the creek. How is kind of what we're trying to figure out. And without going too much into the details of the hydrology and the connection between alluvium and the mountain system, mountains and Tucson and the Basin Range province in particular, the mountains actually receive a lot more precipitation than the basin itself. And the basin, the groundwater in the basin is very hydrologically connected to the rainwater that falls in the mountains. And there are different modes of recharge for that basin groundwater. So rain can fall in the mountains. Some of it will flow down into the alluvium and then go into the aquifer. Some of it will go into the bedrock, which is what the mountains are made of, and stay in that bedrock and then slowly make its way to the aquifer. Some of it will go into the bedrock and then discharge as springs and then recharge the basin flow alluvium, which gives water to the town of Patagonia and Sonoita Creek. Okay, a fractured understanding. So the Patagonia Mountains are composed of bedrock, and it's fractured bedrock, and it's not very well understood. So there's a pun there. So what's tricky about fractured bedrock is that unlike alluvium, where you can predict the water table and you can more or less model groundwater flow, in fractured bedrock, it's very challenging to model groundwater flow, and the the water table is not level. It's high in certain places, low in certain places, isolated in certain places. So it's extremely complicated. And to add to that complicated nature, there's a system of large faults in the Patagonia Mountains that either act as conduits for groundwater flow, so basically act as huge pipes that channel large amounts of groundwater, or act as barriers to groundwater flow. So they can also act as more or less a wall to groundwater. So we know where the fractures are and the faults are, but we don't know their interaction with the flow of groundwater in the mountains. And then this is just a cross-section of the geology. The geology of the Patagonia Mountains is incredibly complex and does not aid us in trying to understand the hydrology of the mountains. And then to add to the complexity, as I mentioned, there has been a lot of historic mining activity. Those historic mines have closed, but they've left a system of tunnels through the mountains. So you can imagine groundwater moving through the mountains. It hits one of these tunnels and it just discharges the land. So imagine the mountains and they're just full of fractures and tunnels, and it's just incredibly complicated. Okay, now we're on to local partners. So the main local partner is this Flood and Flow Committee. And the Flood and Flow Committee is the advisory council to the town council of Patagonia, basically for water issues. So the town council, which makes decisions for the town of Patagonia, has an advisory committee, which is the Flood and Flow Committee. And their looks like committee knocked down. But anyway, their goal is to advise, to make management decisions really around water in the area. And then the other partner is a citizen science group called the Patagonia Area Water Scientists, PAWS. And that's a group of citizen scientists in the Patagonia area that are ready to go out and collect data and information on groundwater movement and surface water movement. Okay, so that's a lot, but this really sets the stage for the rest of the project. And these points are really, really important to understand. So the town of Patagonia has been experiencing a declining groundwater table. The Sonoita Creek is dependent on water from the Patagonia Mountains, right? Drought and increased pumping has led to this high level of concern in the Patagonia area. The hydrology of the Patagonia Mountains is extremely complicated, but there are these two committees that are currently working to address these issues. The Flood and Flow Committee, which makes management and policy decisions, and then the Citizen Science Group, which is ready to go out and collect information. So with this as the stage, we started our research. So this is the flow of the work. We want to improve the understanding of the hydrology via isotopes and geochemistry, my kind of master's thesis in research, and then present our findings to the public, and then pass on a monitoring plan to the Citizen Science Group, and then also a management plan of sorts to the Flood and Flow Committee. So these are the specific objectives from my hydrology master's thesis. Basically, to sum them up, what we're trying to do is we're trying to better understand the connectivity of the alluvial aquifer to the mountain system, right? And also to identify which springs in the mountain system, which directly affect the recharge of the town's aquifer, are most vulnerable to climate change and also pumping. So there's a whole system of springs in the mountains, and those are integral to the water source for the people in the town and the Sonoita Creek. So the first part of my project was finding all these springs. So that was a lot of fun. I got to go wander around the Patagonia Mountains, wander up these dry gullies, and eventually get to a spring. And so why springs? Well, there aren't many wells in fractured bedrock because bedrock is expensive to drill into, and it also yields low flow. So a spring is where the water table actually breaches the land surface. So if you see a spring in the mountains, the water table actually comes down to that point, it breaches the surface and then begins to flow as surface water. So really the spring at its source is groundwater. So we're analyzing the groundwater of the mountains so we could collect samples directly at springs. And these are a few examples of springs or photos that I took. Here are some photos from the field work. Yeah, the Patagonia Mountains are an amazing place. The geology is crazy. That's actually a large fault. So it looks like a large canyon, but it's on a large fault line. There's water out there, believe it or not, even in the middle of summer. Okay, how much time? Okay, so I wanted to describe a little bit about isotopes in geochemistry, mainly because they're really cool tools. I'm not going to go into it that much, but one of the most interesting things I've learned in this project is what hydrologic tools exist to address these very complicated questions. And one of them is stable water isotopes. And stable water isotopes you can use to identify the source of water. Okay, so we take a sample at a spring. That water fell as rain at some point. But through the use of stable water isotopes, we can determine what elevation that rain fell at and what season it fell at. Okay, so it's a really, and how we do this, I'd be happy to explain, but I don't have time. But more or less, you can think of it as a fingerprint. So we can take a sample of water, send it to the lab, get it back, and have an idea of when that water fell as rain. And the other, okay, so these are some initial results. And the most interesting result thus far is that there's this distinct isotopic signature. So basically what that means is these samples are different than the rest of them. So all these samples come from this area, which is on the other side of this large fault line, basically meaning that that fault line probably acts as a barrier to flow. Okay, so that's our first kind of initial hypothesis or finding, that the water which is moving from here, this is high elevation, which is moving this way, hits this fault line and is forced actually downwards, and then actually comes back up on the other side of the fault line and is hotter. All of our analyses indicate hotter water there, and it has this distinct isotopic signature, and it's probably very old water. Okay, so yeah, that's one of our main findings. The other one is that most of the springs are receiving high elevation winter recharge. So what does that mean? We can then look at projected climate models, and if winter rains are going to decrease, those springs might see a decrease in flow. And this is from the Rincon Mountains from another paper. It's similar. So basically the Sky Island area has similar kind of isotopic signatures, so we can learn from other studies in the area. And then without going too deep into this is Tritium Analysis. This gives us a basic estimation of the age of water. And the reason we want to know the age is you can think of the water at these springs coming from a checking or a savings account. If the water is old, you can think of it as a checkings account, okay? So once you take all your money out of your checkings account, is there any money going in? Maybe a little bit. Out of your savings account. So old water, savings account, let me correct that, right? So if you take all your money out of the savings account, there's nothing going in, that water might not come down. If a spring is producing old water, and that water goes away via pumping or lack of via pumping, then that is a vulnerable spring to pumping. However, the checkings account is more vulnerable to climate variations. Okay, so next steps. Late February, we have a well owner training. So I mentioned there's this high level of concern in the Patagonia area. We're going to train well owners on what they can monitor for and what they should monitor for to address those concerns. So we have that training coming up. I'll be presenting my results, and then I have to pass on this monitoring plan based on our results to the Flood and Flow Committee in PAWS. I need to convince another master's or doctoral student to continue doing work, because this work is really fun, and these groups, it's been fantastic working with these different groups. And then I also need to write a thesis and graduate. I've learned a lot in this project, but these are just a few kind of key points. Partnerships, not projects. That came from a paper we had to read for this fellowship. That working on a thesis that's designed around partnerships as opposed to just like doing a project has been really rewarding, and I think the actual outcomes of this may, it won't just be, my thesis hopefully won't just be stored on a shelf somewhere to collect dust, but it might be useful to some people. And then policy depends on science, science depends on policy. It's in the water world, you realize how connected hydrology is to policy, and how the work that we do as hydrologists is connected to the kind of legal framework that exists. And then some acknowledgements. My advisor in the hydrology program, Dr. Jennifer McIntosh, Christine Woolman, who's my out of the university advisor, Carolyn Schaefer, and the Flood and Flow Committee, which is that committee in town of Patagonia, Dave Allison Paws, which is the citizen science group, and then my sources of funding. And if you have questions or concerns, or just want to talk about some of these tools that we use in hydrology, I'd be happy to explain them more in depth. And they're really excellent tools and can answer challenging questions. So then here's a review, and I can take any questions. Yeah.
Your map shows the Harshaw Creek connected to, is it Sonoita Creek?
Yeah.
But you didn't talk about surface water as a source.
Yeah, so surface water is a source. Harshaw Creek is not perennial. It's ephemeral, unlike the parts of Sonoita Creek. But this, yeah, so a lot of Harshaw Creek is fed by springs, right? Even the ephemeral reaches. So if those springs go dry, then that won't feed Harshaw Creek. So it's really like the springs are indicative of the like groundwater health of the Patagonia Mountains. So by monitoring springs, you're in a sense monitoring the like overall groundwater availability of the mountain.
Okay.
So it's a yeah.
You said you're going to do a training for people that monitor the water in the wells.
Right.
What's the monitoring for? What kind of questions will that be addressed?
It's going to be just like basic hydrology of the Patagonia area. Just because doing work out there, we've realized that there's a very low, there's lots of misinformation, I guess, about what future water availability will be. So we want to address those questions. And then there are lots of water quality issues in the Patagonia Mountains. This work doesn't address that. Most of them are surface water quality issues, but those could translate to groundwater quality issues. So a well owner can be vigilant about annually taking in samples to the lab to test for potential contaminants. And also, yeah, when you're drinking your water, you don't know what's in it. So there's a lot of, just to address those concerns.
So empower them to understand their water.
Yeah, and to dispel some of the like speculation, right? Or to reinforce it, you know. But it is if you go down to Patagonia and talk to people about water issues, there's lots of passion behind it, and people want answers, but the answers are super hard to get because it's so complicated. Yeah.
So Sonoita Creek is perennial going upstream. How far?
So there are just a few reaches that are perennial. And the Nature Conservancy actually protects one of those reaches. So
it's a broader groundwater area that really feeds.
Yes, very much. Yes. Okay. So and the majority of the water in Sonoita Creek doesn't come from the Patagonia Mountains. But as other recent research that's been published indicates, is that even a small drop in water table can have a huge effect on perennial reaches and actual surface flow. Because for example, the Santa Cruz River still flows, it just flows underground, right? So you have to bring the water table all the way up. So there's only a few feet of play really you have there, right? Yeah. Thank you. Okay.